This is Science and Public Policy self-video number 4 on the new public policy that I'm proposing for my paper. So the new policy that I'm proposing is to reduce water usage in the United States on the part of agricultural institutions through the widespread adoption of drip irrigation, which is a system of crop irrigation involving the controlled delivery of water directly to individual plants through a network of tubes or pipes. This public policy would include providing rebates and financial incentives for switching to drip irrigation, modeled after the system that the Coachella Valley Water District has recently implemented. First, why do we need this policy? This policy is necessary because it's essential to reduce water usage because of the unsustainable use of groundwater, which means that it's being used faster than it can be replenished by natural processes, decreasing amounts of rainfall throughout the country, and especially the sustained drought in the West, which has been primarily caused by climate change. Weather is the changes in atmospheric condition over a brief period of time, while climate is the general pattern of the weather that occurs for a region over a number of years. Climate change is a departure from the expected average pattern of climate over a region over time. The Earth periodically undergoes periods of warming and cooling, but human interference has also begun to play a role in changing climates because of increased carbon dioxide emissions, which alter the delicate balance of Earth's atmosphere and can have catastrophic consequences. The American West has warmed considerably over the past century because of global warming, which has contributed to the observed loss of winter and spring snowpack in many regions. In the western United States, most water arrives in winter storms, which swoop in from the Pacific and dump snow atop the region's mountain ranges. Mountain snowpacks are essentially frozen reservoirs, with their spring melt supplying as much as 75% of the West's water. The complex system of dams and reservoirs catch and store snowmelt as it fills the region's rivers in spring. More than 700 reservoirs capture the flow in major river basins, bringing water to places that could not otherwise be as populated or as agriculturally productive. These western snowpacks have declined in recent decades because of warmer winters, meaning less snow stored in the mountains and earlier snowmelts, which results in a persistent and worsening drought. As a result, 11 of the past 14 years have seen a drought in much of the American West, from California across to Texas and Oklahoma, according to the U.S. Drought Monitor. Essentially, this is not a problem that's going to disappear, as climate change is very real and greatly affecting both weather and climate patterns. Thus, the United States as a whole must make a conscious effort to reduce water usage in order to ensure that we do not face devastating shortages because of a lack of available clean water. So this policy will be helping to alleviate a pressing public problem. So why this exact policy? Why is this policy being proposed as opposed to different ones? Well, first, urban water usage accounts for just 20% of water that goes toward human consumption in California, with similar trends being displayed across the United States. Most of the remainder, nearly 80%, is used for agricultural purposes. Therefore, if America wants to seriously reduce its water usage, it must not only ask its citizens to moderate and decrease their personal consumption, but also consider serious action to reform the current standards, methods, and procedures used on farms. So, most farms currently use flood or spray irrigation in order to water their crops. In total, about 39% of all the fresh water in the United States goes to irrigate crops. After use, much of this water cannot be reused because so much of it evaporates and transpires in the fields. Therefore, it is vital that farmers adopt the most efficient methods, such as drip irrigation, to irrigate their crops. Flood irrigation is when water is delivered to the field by ditch, pipe, or some other means and simply flows over the ground and through the crop. It is generally assumed that only half of the water applied actually ends up irrigating the crop. The other half is lost to irrigation, runoff, infiltration of uncultivated areas, and transpiration through the leaves of weeds. Although methods have been developed to increase its efficiency, such as leveling fields, surge flooding, and recycling runoff, it will never be as efficient as other types of irrigation. Spray irrigation is often used on large farms. The systems can be simply long hoses with sprinklers along the length or center pivot system with a number of metal frames on rolling wheels that hold the water tube out into the fields, which are moved by electric motors in a big circle around the field, squirting water. In a high-pressure irrigation system, a lot of water, up to 35%, is lost because of evaporation and the blowing winds. A more modern alternative to the high-pressure water guns is the low-pressure sprinkler system, in which water is gently sprayed down toward the plant instead of being shot high in the air. It is more efficient in that less water evaporates or is blown off the fields if there is a strong wind present, but still, again, not as efficient as other methods of irrigation, such as drip irrigation. So what is drip irrigation? Drip irrigation is a system of irrigation involving the controlled delivery of water directly to individual plants through a network of pipes or tubes. Water is sent through plastic pipes with holes in them that are either laid along the rows of the crops or even buried along their root lines. The water slowly drips into the crop roots and stems. If managed properly, drip irrigation can increase yields and decrease water, fertilizer, and labor requirements. Evaporation is cut way down, and water can be directed only to the plants that need it, and up to 1/4 of the water use is saved, as compared to flood irrigation. In order to motivate farmers to adopt drip irrigation, because it is the most efficient system that will reduce water usage, the government should provide rebates and financial incentives to farmers for switching to drip irrigation, modeled after the system that the Coachella River Valley District has recently implemented. They began an initiative to account for the shrinking Colorado River and reduce local agricultural water use by offering rebates to a limited number of local growers who make a change in their permanent crop irrigation systems. They can apply for up to $1,500 worth of rebates for each acre of land that is converted, which will cover approximately 3/4 of the cost it will take to convert their irrigation systems. So, arguments for and arguments against drip irrigation. First, drip irrigation will save water, as demonstrated above. So, it is a way to make sure that the United States becomes more sustainable in its water usage and reduces its overall water usage. For example, the program enacted by the Coachella River Water Valley District will be used to convert an estimated 667 acres of dates and other trees from flood to drip irrigation for a total savings about 2,000 acre-feet of water that is taken from the river annually, which is about 651 million gallons that could be saved every year. Converting only 666 acres of farmland to drip irrigation will save millions of gallons of water. So one can only imagine how much water would be saved if drip irrigation became widely used on farms throughout the United States. Also, they would argue that it saves money. So while the initial cost of installing drip irrigation can be expensive, sometimes as much as 40 to 50% higher than installing a center pivot system for spray irrigation, growers can expect to see those costs paid back within 2 to 5 years because of better water use efficiency and lower irrigation energy bills, as the drip system typically uses 65 to 75% of the water and energy needed to irrigate a pivot and often uses less than 1/3 of what flood irrigation uses. Next, we turn to arguments against. So first, they would argue that those initial costs are really high. So even if the government offers rebates to reduce the cost to farmers, they will still have to shoulder some of the costs, which can amount to anywhere between $1,200 and $3,000 per acre of farmland. Another argument is that even if farmers cut back on their water usage, it will only go so far to alleviate the country's water woes, because farmers must continue using drip irrigation to water their crops. So different solutions must be researched, particularly those dealing with supply. New ways to produce and move water must be researched and implemented in order to address water shortages effectively and adequately, such as desalination and the construction of more dams. Okay, now we turn to the science behind drip irrigation. So there's numerous studies and there's numerous reports which support the efficiency of drip irrigation. It's been testified to by numerous studies and widely accepted in both the scientific and agricultural circles. So there's not that much of an obstacle in that regard because it is sound. The only technical obstacle to the policy would be that although drip irrigation systems can be easily put into place on both square leveled fields as well as oddly shaped or uneven fields, and the equipment is not too difficult to install, they do require routine maintenance, as emitters can become clogged, valves, filters, flow meters, pressure gauges, and other system components can become worn, and pipelines and components must be winterized in colder climates. So it does need constant monitoring, which could be a setback because not all irrigation systems require that much monitoring. The political obstacles to the formulation and implementation of drip irrigation on farms. So people that would oppose this policy would probably be farmers who probably can't afford the initial cost of drip irrigation and don't want to convert their systems, as well as conservatives who support minimal government, regulation, and small government. So they would not want an additional policy that the government has to regulate. And citizens and public officials who want to reduce government spending might oppose this policy because if the government offers rebates, the debt will increase. So while some farmers may oppose the formulation of such a policy, other farmers will welcome it, as rebates might help them adopt drip irrigation, which they had been considering for years since they know it's more efficient both in water usage and long-term costs, but had not been able to afford because of its high costs. Also, environmentalists would support the policy because it makes use of innovative and efficient technology, which helps the environment by reducing the amount of groundwater and resources depleted by agricultural use.